picture this, right? A patient walks into a clinic, and before they've even taken a seat, before they've even, fully articulated why they're there, the clinician already has a highly accurate working
Oh,
diagnosis.
yeah. It honestly looks like magic if you're just watching it happen.
Right. It looks like a literal superpower.
Yeah.
But usually when we talk about learning a new skill to reach that level, we tend to imagine it as this purely mental shift, like downloading a massive file.
Yeah. You read the textbooks, you memorize all the pathologies, and you just carry that new database around in your head.
Exactly.
It's that classic filling the bucket analogy of education, just pouring more data into the exact same old container.
But when you actually step into the world of true, high-level clinical expertise, that data download metaphor completely shatters.
Right.
Because we're looking at a transformation that isn't just about what a person knows. It fundamentally, physically changes the container itself.
Oh, absolutely. It's the absolute definition of biological remodeling. I mean, it's structural, it's physiological, and it completely rewires how a person perceives reality.
And that is exactly what we're exploring today. So welcome to today's deep dive. We are looking at a truly fascinating presentation from Dr. Christophe Delong and Kinexa Formation.
It's a fantastic piece of work.
It really is. And our mission today is to completely upend how you think about mastery. We're going to explore how becoming a true expert doesn't just, change your knowledge base, but literally alters the architecture of your brain.
Yeah, going all the way from the microscopic cellular level
Right.
all the way to a very concrete, actionable framework that you can use to hack your own learning.
Okay, let's unpack this, because if we want to understand how experts can think and diagnose so incredibly fast, we have to start by looking at the physical hardware upgrades happening inside their skulls.
That is the crucial foundation because, look, this transformation is a cascade of neuroplasticity, but it doesn't just happen at random. It unfolds over very specific, measurable timelines.
So it's not something that just clicks overnight.
Definitely not. If we look at the very short term, and by short, I mean like milliseconds to hours, what you're seeing are changes in synaptic efficiency. It's a process known as long-term potentiation, or LTP.
Okay, so if I'm a medical student, right, and it's my very first day learning a brand new clinical exam sequence, what is actually happening physically in my brain when I practice that?
Well, when you're stumbling through that sequence for the first time, you are forcing a specific network of neurons to fire together. And in those first few hours, down at the microscopic level, you have these cellular gatekeepers.
Gatekeepers.
Yeah, they're called NMDA receptors. When a neuron fires strongly enough, these NMDA receptors actually pop open, and they allow this flood of calcium ions to rush right into the cell.
Wow, okay, so the calcium is doing what exactly?
It's the biochemical trigger. It
Hmm.
physically strengthens the connection between those specific neurons. It's basically the brain's way of saying, hey, we're using this exact pathway right now. Make the signal louder.
Right, but if I stop practicing, that signal just fades, right? I mean, it's like writing something in the sand. So how does the brain actually hit save on the document?
Ah, that happens in the medium term. We're talking days to weeks here. And this is where sleep becomes absolutely critical.
Really? Just sleep?
Yes. During sleep, particularly through this process called hippocampal reactivation,
Mm-hmm.
the brain is quite literally replaying those new clinical patterns you learned during the day.
Wait, almost like a sports team reviewing game tape overnight to solidify a new play style. Like the physical pathways are being paved while the stadium is completely empty.
That is a brilliant way to conceptualize it, honestly. While you're asleep, the hippocampus fires off those exact same sequences, but often at incredibly high speeds.
Mm-hmm.
And this stabilizes the functional networks in the cortex.
And we can actually see this happening.
Oh yeah, we know this isn't just a theory. Because if you were to measure the brain with an EEG or TMS, which is transcranial magnetic stimulation, you'd see that the baseline excitability of the cortex has shifted.
So the brain is taking those temporary calcium-based connections and making them more permanent.
Exactly. Which brings us to the long term.
And long-term means, what, months to years of deliberate practice?
Right. And this is where we see actual macroscopic structural remodeling of the brain. Like you can see local changes in the volume of gray matter. The brain is literally building more raw processing power in specific areas.
That's wild.
But even more crucially, you see massive changes in the white matter.
Okay, the white matter, that's basically the cabling that connects different regions of the brain, right?
Yes.
The presentation specifically mentions axonal myelination. But how exactly does wrapping a nerve in myelin, speed up a thought?
Well, myelin is essentially an insulating layer of fat. If you think about an electrical wire without any insulation,
The power would just bleed out everywhere.
exactly, the electrical signal leaks out as it travels down the wire, which slows the entire current down.
Yeah.
By wrapping these heavily used neural cables in myelin, the brain prevents that electrical leakage.
So the signal gets trapped inside.
Right, so the electrical impulse can now literally jump rapidly down the nerve fiber. It drastically speeds up signal conduction. And alongside this, the brain is also expanding its somatotopic maps,
Meaning what, exactly?
meaning it's dedicating more physical real estate in the motor and sensory cortex, specifically to these expert tasks.
So specific regions of the brain are literally morphing based on the job they have to do. Like take the visual cortex, for example. The sources note that an expert's visual cortex refines its feature detection.
It does. It gets much, much sharper.
It gets better at spotting tiny postural asymmetries or like behavioral microsaccades that a novice wouldn't even register as visual information.
Yeah, the visual cortex basically upgrades its camera resolution. And simultaneously, you've got the basal ganglia, specifically a region called the striatum, working as the ultimate organizer.
Organizing what?
It takes what used to be a really clunky sequence of, say, 10 different clinical observations, and it chunks them together into one single automated routine.
Oh, wow.
And you also have the cerebellum. We usually associate the cerebellum with basic physical balance, right? But in an expert, it is hyper-tuning its predictor models. It is constantly anticipating the patient's physical dynamics before the patient even moves.
And driving all of this is a very specific neurochemical cocktail. I mean, it's not just electricity, it's a chemical bath.
A highly calibrated chemical bath, yes. First, you have dopamine. We often hear dopamine called the pleasure chemical.
Yeah, like getting likes on social media.
Right. But in learning, it acts as a prediction error signal. It rewards you when you get a diagnosis right, which cements those new diagnostic habits. Then you have acetylcholine.
What does that one do?
It massively spikes your focus and actually opens the window for neuroplasticity during the learning phase. And finally, there's noradrenaline.
Okay, noradrenaline.
This kicks in during highly emotional or rare clinical cases. It acts like a neurological save button. It basically sears those unusual presentations in your long-term memory so you never miss them again.
Is this basically like upgrading a computer from a clunky old hard drive to a lightning-fast solid-state drive, but with the added twist that the motherboard actually changes its physical shape depending on what software you run?
What's fascinating here is that your analogy perfectly captures the mechanism, especially when you consider the metabolic energy costs.
Oh, the energy costs, right?
Because here is the real kicker. When you look at an expert's brain in an fMRI scanner, while they're performing a familiar clinical task, their prefrontal cortex, which is the heavy-lifting, conscious, analytical part of the brain,
Right.
it actually quiets down. It uses less oxygen, less glucose.
Wait, really? They're doing something incredibly complex but using less brain power to do it.
Exactly. This physical efficiency, the myelination, the chunking, and the basal ganglia, it allows the brain to conserve immense amounts of metabolic energy.
That is mind-blowing.
If you look at an EEG or a MEG scan of an expert, you see much shorter response latencies. But more importantly, you see gamma and beta brain waves syncing up across different regions.
Like an orchestra suddenly playing in perfect time.
Yes, they've built a custom motherboard that runs the software with almost zero friction.
But if the brain is physically rewiring itself to be this incredibly efficient, how does it actually process information in the moment? Because clearly this clinician isn't standing there consciously running through a mental textbook step by step.
No, absolutely not.
The sources detail how experts process information in what Dr. Delong and Kinexa formation call a dual flex system. Two completely different parallel tracks.
Understanding this dual flex system is the absolute key to understanding clinical mastery. Let's start with the first track, the implicit track. This is the fast system. It operates in under 500 milliseconds.
Under 500 milliseconds. That is literally the blink of an eye. We aren't even consciously aware of a thought at that speed, are we?
We aren't. Your conscious brain simply cannot operate that fast. This implicit track relies heavily on the basal ganglia, the cerebellum, and those visual parietal pathways we just talked about.
Because it's already wired up.
Exactly. Because it is so highly myelinated and automated, it recognizes patterns instantly. This is the precise mechanism behind clinical intuition.
Wow, intuition.
It's that immediate gut feeling of, oh, this feels like an L5 spinal issue, triggered by just a minuscule instability in the patient's gait or a tiny timing mismatch in their muscle activation.
So intuition isn't magic, it's just ultra-fast, heavily myelinated pattern recognition.
Spot on. But running parallel to that and lagging slightly behind is the explicit track. This is the slow system. It takes over 500 milliseconds to kick in.
And what's running that one?
It relies heavily on the dorsolateral prefrontal cortex, the DLPFC, and the hippocampus. This is your conscious analytical brain.
The voice in your head that actually thinks in words and sentences.
Precisely. And the expert pipeline always follows a specific sequence.
Yeah.
Intuition, then verification, then explicitation.
Okay, break that down for me.
The fast, implicit track delivers the gut feeling. Then the slow, explicit track kicks in to verify it, pull up declarative facts to eliminate false positives, and ultimately explicitly justify the diagnosis.
The presentation calls the implicit track the invisible control. And it blew my mind to read that it's so powerful, it actually guides the experts' eye movements, their saccades, to the right place before they even consciously decide to look there.
Yeah, the eyes move before the conscious thought even forms.
And it silently eliminates 95% of possible diagnoses, so the conscious brain doesn't even have to wade through the noise.
It acts as an incredibly efficient automated filter.
But wait, I have to push back on this a little.
Okay, go ahead.
If this implicit under 500 millisecond system is so incredibly accurate and it's doing all the actual heavy lifting of filtering and recognizing patterns, why do we even need the slow explicit brain anymore? I mean, isn't the explicit brain just playing PR manager at that point? Just, coming up with a smart-sounding narrative to justify the gut feeling to the patient?
That is a very common assumption, that the slow brain is just there for show. But it's not just a PR manager.
No.
Think of the explicit brain, particularly the DLPFC, as the crucial quality assurance department.
Oh, QA. Okay.
Yes, it builds the narrative to communicate with the patient, sure. But its primary job is testing the implicit intuition. When the FAST system flags something that feels even slightly off, like a subtle anatomical mismatch or a statistical improbability,
It catches it.
the explicit system slams on the brakes. It forces the clinician to hold those competing facts in their working memory, pull up their declarative knowledge of anatomy and biomechanics, and systematically verify the findings.
So it's the safety net. Without it, you're entirely at the mercy of your automated assumptions.
Exactly. The intuition might be right 95% of the time, but the explicit track is what prevents catastrophic errors the other 5% of the time.
And that perfectly sets up the massive trap hidden inside this biological upgrade. The dark side of automation.
It's a real danger.
Because relying on a lightning-fast subconscious system isn't foolproof. If your brain is physically rewiring itself to ignore unnecessary data to save energy, aren't you inevitably going to start missing things?
You hit the nail on the head. The profound irony of expertise is that the very mechanisms that make you brilliant can also make you dangerously blind.
Right.
The primary danger here is overconfidence. And that leads directly to something called inattentional blindness. Because your brain is so brutally efficient at filtering out irrelevant data, it can completely mask entirely new signals.
Meaning, if a patient presents a symptom that doesn't fit your highly trained pattern,
Your brain might literally refuse to process it visually or cognitively.
and the sources point out that this feeds right into confirmation bias, where your implicit prediction is so incredibly strong you think, oh, this is just another standard rotator cuff issue, that you actively ignore contradictory clues that are right in front of your face.
Right. And this is heavily exacerbated by habituation. When clinical practice becomes too monotonous, when you're just seeing the exact same types of typical cases day in and day out.
You just tune out.
Yeah, the brain's attention to subtle differentiating signs actually thins out. The hardware gets lazy because it doesn't need to adapt anymore.
This sounds exactly like highway hypnosis. You know when you drive the exact same route home from work every day on total autopilot?
Oh, yes.
You pull into your driveway and suddenly realize you have no memory of the last 5 miles. The implicit system was driving the car. But in a clinical setting, what happens if someone put up a new stop sign while you were zoned out?
That is a fantastic analogy. If there's a new stop sign or in medicine, a rare pathology that mimics a common one, you run right through it without even touching the brakes.
Which is terrifying.
It is, which raises a critical question. How do we prevent the expert brain from falling asleep at the wheel?
Right. How do we fix it?
The mitigation strategies detailed by Dr. Delong in Kinexa formation are very pragmatic. First, you have to institutionalize reflexive pauses.
What does that actually look like in practice, though? How do you pause an automated process?
It means artificially creating friction, using strict 10-second internal micro checklists, before finalizing any diagnosis.
Just a 10-second pause.
Yeah, you're intentionally forcing your explicit brain to test an alternative hypothesis. No matter how supremely confident your implicit brain feels, you have to ask yourself, if I am completely wrong about this, what else could it be?
Forcing that QA department to do its job.
Precisely. Sometimes it means deliberately consulting a colleague or even an AI diagnostic system simply to disrupt your own echo chamber. And crucially, it requires true deliberate practice.
Varying the routine.
You have to intentionally vary the cases you see. You must expose yourself to rare pathologies and clinical mimickers, conditions that look identical to the standard pattern but aren't, just to prevent your neural pathways from becoming too deeply rutted.
Which brings us to the most actionable part of this deep dive, hacking the system. Because if we want to avoid those blind spots, and if we want to somehow pass this clinical superpower on to someone else, we need a way to train and extract this invisible, implicit knowledge.
It's the holy grail of medical education.
But how do you extract something the expert isn't even consciously aware they're doing?
It is incredible. They also use eye-tracking software, which is often spectacular to see, because it shows where the expert's gaze actually landed, which is rarely where they thought they were looking.
Wow.
And they use think-aloud protocols, forcing the expert to verbalize their micro-decisions in real time. Like, why did you test this specific segment first instead of the one next to it?
And by breaking down those micro decisions, you can start to build actual interventions to boost a student's expertise. Things like deliberate practice with immediate feedback.
Right.
The example given is spending 10 minutes hyper-focused solely on spotting scapular asymmetry on a video and getting corrected instantly every time you were wrong.
Yes, because that immediate feedback is what triggers that dopamine error correction signal we talked about, cementing the new pattern.
Makes total sense.
They also emphasize mental simulations. Closing your eyes and vividly imagining the sequence of an exam actually activates the exact same motor and premotor brain circuits as doing it physically.
Just thinking about it wires the brain.
Literally. And as we mentioned earlier, enforcing strict sleep hygiene to ensure the hippocampus actually consolidates the day's learning.
Here's where it gets really interesting to me, though. If you're listening to this and thinking, okay, this is fascinating, but how does someone actually teach this?
That's a huge hurdle.
If so much of this high-level expertise is subconscious, nonverbal, and happens faster than a blink, how on earth do you write a curriculum for it? How do you teach a medical student to feel something they literally don't have the brain structure to see yet?
That is the ultimate challenge, isn't it? The key, according to Kinexa formation, is that teaching must always combine execution with justification.
Meaning?
You cannot just show the student the physical gesture. You have to explicitly explain the mechanism and the why behind it. You have to explicitly name the chunks of information.
Give them the labels?
Right. If an expert's implicit brain recognizes a complex postural signature, they have to consciously break that signature down into its 5 distinct component parts for the student.
So they can start building their own chunks.
Yes. And you have to construct a curriculum that progresses very intentionally. You start with highly typical, perfectly clear cases. Then you move to noisy cases with distracting, irrelevant symptoms.
This is train the filter.
Exactly. And finally, you move to highly atypical cases. You are systematically building their internal database of myelinated patterns.
So if you want to apply this to your own life, Dr. Christophe Delong and Kinexa Formation have laid out a really incredible pragmatic action plan, like a literal roadmap for hacking your own expertise.
It is a brilliantly structured progression.
Let's break it down for everyone. Days 1 through 7. You start by recording videos of 10 cases a day. You review that tape for just 5 minutes, and you force yourself to explicitly note 3 key clues you used.
Which forces the bridge to form between the implicit observation and the explicit justification.
Exactly. Then, at the 30-day mark, you analyze your own attention patterns, like where are you getting stuck? And you deliberately introduce case variability so you don't fall into that highway hypnosis.
You're intentionally forcing the brain off the familiar, highly myelinated route.
Right. Then, at 90 days, you strictly evaluate your performance metrics. Are your detection times getting faster? Is your diagnostic concordance improving?
Meaning, does your diagnosis consistently match the gold standard or other top experts?
Yeah. And finally, at 1 year, you step back and compare the qualitative and quantitative changes in your practice. If you follow this, you have effectively remodeled your own brain.
It is a remarkable blueprint for deliberate evolution.
So what does this all mean? We've gone on quite a journey today. We started at the microscopic level, looking at how learning physically remodels our synapses with calcium, builds white matter insulation to speed up signals, and shifts our cortical excitability.
The hardware upgrade.
Right. We explored the lightning-fast, under 500 millisecond implicit intuition that silently guides an expert's eyes and filters out 95% of the noise. We confronted the dangerous blind spots of automation. And we walked through Dr. Christophe Delong and Kinexa Formation's pragmatic action plan for actively building and extracting expertise.
It's a lot to take in.
It is. And I think the biggest takeaway here is that whether you are a clinician diagnosing a complex pathology, an engineer debugging a system, or an artist mastering a medium, mastering your craft isn't just about collecting facts. You are literally physically sculpting your own brain.
If we connect this to the bigger picture, it leaves us with a truly provocative thought.
Oh, I like the sound of that.
If human clinical expertise is fundamentally based on this implicit, automated pattern recognition that happens in under 500 milliseconds, what happens when we successfully map these exact extraction protocols into artificial intelligence?
Oh, wow.
Will machines learn to see these invisible, complex biomotor patterns faster and more accurately than our own basal ganglia? And if so, how will the role of the human expert evolve when the magic of intuition becomes just an algorithmic baseline?
That is a wild thought to leave off on. We've gone from the magic of the master clinician right down to the physical wiring, and now peering into a future where that wiring might not even be biological. Thank you so much for joining us on this deep dive. Take that 30-day action plan, see what you can rewire in your own expertise, and we'll see you next time.